Welcome back to the new session. It is part 9, standard 10th maths, chapter 6, triangles. Well, yesterday we began, or in the previous session we began to solve exercise 6.2 and first 6 questions were solved. Today we'll proceed further. First we shall solve the 7th question. Very interesting. Alright. Using theorem 6.1. You have to prove this statement using theorem 6.1. Can you recall what is theorem 6.1? Yes. If a line is drawn parallel to one side to intersect the other two sides in two distinct points, then that line divides the other two sides in the same ratio, same proportion. Alright? Take it. Prove that a line drawn through the midpoint of one side, a line drawn through the midpoint of one side of a triangle and parallel to other side bisects the third side. Children, here it is. We have triangle ABC. Line L is drawn through the midpoint of one side. AB is the first side. Its midpoint is M. You can see I have put some symbols here which represents that M is midpoint of AB. AM equal to BM. So M is midpoint. So line L is passing through midpoint of side AB. It is parallel to BC. We have to prove that it bisects the third side. You know, it passes through the third side. ऐसा एक statement है. A line passing through any one side and parallel to other side always intersects the third side. But there is one condition. A line should not pass through the vertex endpoint. A line intersecting any side of a triangle, not at its endpoint, anywhere other than endpoint, and parallel to second side will always intersect the third side. That is a statement of one of the theorem learnt in standard 9. Okay. What is that statement? I repeat. A line intersecting or passing through any side of a triangle, not through the end point, and parallel to second side will always intersect the third side. So here is that line L passes through midpoint. That means it is not passing through the end point. It is parallel to second side. So it will always intersect the third side, AC. Suppose in point N. Suppose in point N. So what we have to show? This N is midpoint. What we will have to prove? N is midpoint of AC. Means we have to show AN equal to CN. AN equal to CN. A dash N dash C तो है ही. Because, okay. कैसे prove करेंगे? We have to use theorem 6.1. Before we see to this, it is very easy. We'll see how we proved in 9th standard. 9th standard में आपने कैसे prove किया था? Children, I have to prove, वो theorem 9th standard वाला पहले use कर देते हैं. कौन सा? This is line L passing through midpoint. Line M is passing through midpoint of side AB and it is parallel to BC. So it will intersect the third side. Suppose in point N. Suppose in point N. Now there are many results or theorems that you have to use here. Beginning is also difficult. Children, what I do? Here is line segment AB. So you can imagine a line. You can produce AB to whatever length you want. So AB is produced. So you get a line. Point C is outside it. Point C is outside it. Through point C, I draw a line M. Here, this is line M, which is parallel to AB. Alright. So, let line M be parallel to AB and it intersects N in point D. It intersects M in point D. Children, now very interesting. Well, M is midpoint of AB, so AM equal to MB. Correct? Now, look at these two triangles. ये दो ट्राइंगल को देखो आप, AM is parallel to CD. Line AM is parallel to line CD, and AC is their transversal. Am I right? So this is an alternate pair of angles. So angle MAN, I'll write here, angle MAN is equal to angle NCD. Angle NCD. Correct? Okay? Sure? Now, this angle is equal to this angle. Am I right? Why? Vertically opposite angle. A and M. Angle A and M. Alright? Is equal to A and M is equal to C and D. Angle C and D. Alright? So two angles are equal. Okay? So, children, one thing you have to observe here, you are not going to get this directly. There is one, we need one more part to show that these two triangles are congruent. Now see, this one is parallel to this one. ये पूरी line parallel है, so you can say BM is parallel to CD, correct? And BC is already parallel to L, so BC is parallel to MD. So MD and BC, one pair of opposite side parallel. MB and CD, the other pair of opposite side also parallel. So quadrilateral BCDM is a parallelogram. So you can say BM equal to CD. You can say BM equal to CD. Correct? And BM is also equal to AM. BM is also equal to AM. So what can you say, children? AM equal to CD. AM equal to CD. I'm not going in detail. This is 9th standard proof. Okay? So, which condition is satisfied? Angle, side. Yeah, ये condition है. So, by angle, side, correspondence. चलिए. MAN corresponds to dash, is congruence. चलो. A corresponds to C. A बीच में, C बीच में. N corresponds to N. N last. C और N आ गया, बच गया D. Correct? Therefore, यहां से मिल गया AN, CN. Therefore, AN is equal to CN by CPCT. Correct? AN is equal to CN and A dash N dash C. A dash N dash C वो तो है ही. Therefore, N is midpoint of AC. N is midpoint of AC. Therefore, L bisects AC. Prove. This is how we prove. This is how we proved in standard 9 using congruency of triangles. Alright, but for that construction was required. Alright, forget about that right now. Okay, we are going to prove by theorem 6.1 of standard 10, which is very easy. बहुत आसान है. It's quite easy. Alright. Alright, I'll erase the statement as well, so we have enough space to write the proof. Okay. I'll write the data here first. Data. Figure draw करो पहले, then write data. L bisects AB at M. Correct? That means L is passing to the midpoint. And L is parallel to BC. This is all that we have in the data. Information में इतना है. to prove L bisects AC also, the third side. Okay. Proof. पहले तो ये पॉइंट नहीं है चल रहा है, L intersects the third side, वो बताना पड़ेगा. All right. L bisects, I'll use this, AB at M, and L is parallel to BC. Therefore, L intersects AC. That means it intersects the third side. Suppose in point N, by theorem of standard 9, so no need of writing the statement, theorem number. All right. अब बताइए, line L is parallel to BC and it intersects the other two sides AB and AC in point M and N. So you can use the theorem 6.1 of standard 10. Then now L is parallel to, all right. Now in triangle ABC, L is parallel to BC and it intersects what? The two sides, other two sides, AB and AC, respectively, in points M and N. Therefore, बोलिए, AM upon BM, AM upon BM is equal to AN upon CN, AN upon CN. Result 1 by theorem 6.1. The number is fresh in our mind, so we can write. चलिए, मुझे तो प्रूव करना है AN equal to NC. We have to prove AN equal to NC. चलो यहाँ एक चीज लिख देता हूं मैं. L intersects AC in point N, no? So therefore, A dash N dash C, and this is result 1, or इसको result 2, because that will be required to show that N is midpoint. बताता हूं क्यों. Suppose this is line segment AC and N is here. AN equal to CN. They are equal. N is equidistant from ANC. But you cannot say N is midpoint. N is midpoint of AC only if it is on it. Here also AN equal to NC and N is on AC. So A dash C dash N dash C. Then only you can say N is midpoint. That's why this is essential here. A dash N dash C. Alright? And next we will have to prove AN equal to CN. So you can say N is midpoint of AC. Fine. AN और CN मिला है. चलिए, मैंने इसको यूज नहीं किया है अभी. L bisects AB at M. Now, L bisects AB at M by data. Therefore, you can say AM equal to BM. If M bisects AB means M is the midpoint. So AM equal to BM. Therefore, AM equal to BM. Children, since here ratios are involved, I am going to express this in the ratio form. Therefore, AM upon BM is equal to 1. Result 3. Children, AM upon BM, AM upon BM. That is 1. So if you can substitute here, see left hand sides are same. So right hand sides are equal. You can use Euclid's property as well. So by 2 and 3, it follows that AN upon CN is equal to 1, which implies therefore CN उधर ले चलो, AN is equal to CN. Result 4. 1 कहता है A dash N dash C, N is a point on AC, और 4 कहता है that N is equidistant from A and C, AN equal to CN. So now you can say by 1 and 4, it follows that N is midpoint of AC. Therefore, L bisects AC. I'll write here. By 1 and O, it follows that N is midpoint of AC. Therefore, L bisects AC. Proved. Clear to you, children? Sure? So fine. Let's move on to the next sum. Alright? Okay. The fan is on, so it makes a lot of noise. Fine. Using theorem 6.2, that is sum number 8 of exercise 6.2, prove that the line joining the midpoint of any two sides of a triangle. You can see the figure. I have drawn a triangle. Two sides AB and AC are taken. Line joining the midpoint. D is midpoint. So I'll put that symbol. D is midpoint. So this cross marks AD equal to BD. And also the midpoint of other side. So this symbol shows AE equal to EC. So the line joining the midpoint of any two sides. D is midpoint of AB. E is midpoint of AC. And a line joining the midpoint. Okay. Is parallel to third side. It is parallel to BC. That is what we have to prove. It's parallel to BC. It's parallel to BC. Right? You have to prove that it is parallel to BC. DE is parallel to BC. In other words, L is parallel to BC. Okay? But you have to use theorem 6.2. What is theorem 6.2? If a line intersects two sides of a triangle in such a way that it divides those two sides in equal ratios, then the line is parallel to the third side. So, दो equal ratio मुझे prove करना होगा AD upon BD equal to AE upon CE. यदि ये लाइन ये दो साइड को इक्वल रेशियोज में डिवाइड करती है, मींस AD upon BD is equal to AE upon CE, then the line is parallel. ठीक है, वो अभी साइड पे रखते हैं. I have drawn similar figure here. Okay, this also was proved in standard 9. Very lengthy, difficult. This 9th standard proof is very easy. Sorry, 10th standard proof is very easy using this theorem. Okay, fine. पहले 9th standard का देखते हैं proof. Children, या ये symbol कर देते हैं. D is midpoint of AB. E is midpoint of EC. E is midpoint of AC. Children, आपको दिखता है ये E midpoint है. So on this line or DE, I'm going to produce till D such that DE equal to ED. You have DE, line DE. I'm producing it till D in such a way, somewhere you will, oh, D is already there. So I'll have to take some other point. Let's say P. Okay, D is already here. So DE equal to PE. हुआ क्या नहीं? DE equal to PE. Children, now look. AC and PD. They are bisecting each other. AC and PD. E is midpoint of AC and E is also midpoint of DP. So if you join this A, C, D and P, you are getting a quadrilateral whose diagonals are bisecting each other. So this quadrilateral is a parallelogram. This quadrilateral is a parallelogram. So AD will be equal to PC. Opposite sides are equal. Now AD में मैंने cross mark किया, तो this is also cross mark. AD equal to PC and AD equal to BD. So now you got BD equal to PC. ये दोनों equal हो गए. Correct? One more thing. AD is parallel to PC. The red quadrilateral is a parallelogram. So PC is parallel to AD. And we have A dash, D dash, B. So you can say PC is parallel to line AB. Yeah, line BD. So look here. This one and this one. They are parallel. PC is parallel to BD. And PC is also equal to BD. BD. PC is parallel to BD and PC is also equal to BD. So again one theorem of standard 9, quadrilateral BCPD. ये पूरा quadrilateral कर दो तो it's a parallelogram because it's one pair of opposite side is not only parallel but also congruent या equal. So it's a parallelogram. So quadrilateral BCPD is a parallelogram. If it is parallelogram, then its opposite sides. ये एक opposite side हुआ कि नहीं? They are parallel by definition of parallelogram. That means DP is parallel to BC. By DP को आप DE भी कह सकते हो. DP को because D dash E dash P is parallel to BC. या आपको DP को L कहना हो तो L कह सकते हो. L is parallel to BC. Got it, children? Got it? Alright. If you remember, DE is parallel to BC and the other result is also there. DE is half of BC. It is not only parallel, but the length of that line segment joining the line joining the midpoints of two sides is half the third side. Okay, fine. So that was how we proved in 9th standard. Alright, now this proof is quite lengthy and difficult as well. But 10th standard proof using theorem 6.2 is quite easy. Kaise? Let's see. I'll write the data first. Or for data, I need that statement. A line joining midpoint of any two sides of a triangle. Which is the line joining the midpoint? So I can say D and E are respectively, this is in the data, respectively the midpoints of sides AB and AC of triangle ABC. ठीक है? What else? बस वही दिया है, वही दिया. And you can say, all right. That's it. All right. It intersects AB and AC in D and E. To prove DE is parallel to BC, or you can say L is parallel to BC. All right. I won't need much space to write the proof, so I'm writing it directly without erasing that statement. Proof. Children, when can you say DE is parallel to BC? Theorem 6.2. If AD upon BD is equal to AE upon CD. If this line DE divide AB and AC in equal ratio. चलिए वो तो लाना है, लेकिन हमारे पास डेटा में क्या है? फर्स्ट, D is midpoint of AC. In triangle ABC, D is midpoint of AB. This is by data. I may write in the bracket by data. Oh, midpoint, then by definition, AD equal to BD. Therefore, AD equal to BD. Sorry, I wrote upon. AD is equal to BD by definition of midpoint. Therefore, AD upon BD is equal to 1. Result to 1. Correct? उसी तरह E is midpoint of AC of triangle ABC. Alright? So by data, therefore AE equal to EC. Correct? So I am going to write that. Similarly, E is midpoint of AC. Therefore, we get, I am writing directly because I have used the word similarly. AE is equal to EC. That means AE upon CE. AE upon CE is equal to 1. Result 2. This ratio is 1. This ratio is also 1. That by 1 and 2. It follows that AD upon BD is equal to AE upon CE. Result 3. And that you got by 1 and 2. That we have already written. Here we have written, so no need of writing it. Now you got AD upon BD equal to AE upon CE. That means D is parallel. Therefore, DE is parallel to BC by theorem 6.2 proved. Clear to you? Understood? So fine children, we move on to the ninth sum now. What is the statement? Let us see. ABCD is a trapezium in which AB is parallel to DC. Your CD you can say. Can you recall what is a trapezium? Yes, it's a quadrilateral having one pair of opposite side parallel and the second pair of opposite sides is non-parallel. Here is the figure. Quadrilateral ABCD is given. AB is parallel to CD. Okay. And its diagonals intersect each other at point O. Very clearly, the blue segments AC and BD are the diagonals. They intersect at point O. They intersect at point O. Show that AO upon BO is equal to CO upon DO. Children, जो prove करना है, they are equal ratios. They are equal ratios. What can produce equal ratios for you? Number one, triangle similar to triangle. ये एक चीज आपको equal ratios दे सकता है. Number two, ये condition, a line parallel to a side to intersect the other two sides in two distinct points. एक नहीं, 5 pairs of equal ratios देता है ये कंडीशन. यहां आपको 3 equal ratios मिलता है. सो आपको इस दो चीज के बारे में सोचना है. If you have to get equal ratios, if these two situations can produce equal ratios for you, then you will have to think of them. Let's see what is going to work for us. चलिए, first let's see if two triangles are there, AO and CO. AO, that is this. आपको ये प्रूव करना है. NCO, AO and CO ऊपर वाले दोनों सेम ट्राइंगल के होने चाहिए. तो देखो AO और CO वो तो एक ही लाइन पे है. तो पहले इसका इन्वर्टेंडो कर दो. AO CO comes down and BO goes up. करेक्ट. ऑल्टरनेंडो याद है क्या? जो भी प्रूव करना है उसका ऑल्टरनेंडो कर दो. तो AO और BO, AO and BO, you can see these are the sides of the same triangle. Now this, if I make it green, CO, this one, and DO, this one. Yes, these are also sides of the same triangle. इसको भी green कर दूं पूरा triangle, इसको भी black कर दूं पूरा triangle. ये children, पहली वाली कंडीशन है, दो ट्राइंगल मिलते हैं. This green triangle contains this two green sides. This black triangle contains this two black sides. If we succeed in showing that green triangle is similar to black, yeah, this green and black triangles are similar, then it is going to produce 3 equal ratios for us, and this two would be there present in it. Are you getting me? Let's see. First we'll write the data. Quadrilateral ABCD is a trapezium that is given. AB is parallel to CD या DC, and diagonals AC and BD intersect at O. To prove, well, AO upon BO is equal to CO upon DO. Children, ये प्रूव करना है, लेकिन आने वाला ये है. You see that? How we change that? AO और BO एक साइड का है. So you will get that, and then you do alternando, then cross multiplication. Not cross multiplication, but alternando, and you will get this. Okay? I think you have understood, so I'll erase this statement now, and we can use that space for proof. Today I am wasting lot of time in erasing this board because I am doing only one sum at a time. Okay, now proof. I'll start from here. Proof. बस ये दो ट्राइंगल प्रूव करना है. They are similar. They are similar. Then you can get equal ratios. Oh children, green angle COD and a black angle AOB. They are equal. What is the reason? Vertically opposite angles. फिर ये parallel lines है. कंडीशन को बराबर एक्सप्लॉइट करो. डेटा में है, इंफॉर्मेशन में है, AB is parallel to CD and that is transversal. AC भी ट्रांसवर्सल है, BD भी है. Okay, let me consider this. ये ट्रांसवर्सल और ये पैरेलल लाइन. ऑलराइट, तो ये Z फॉर्मेशन हुआ कि नहीं? इसको क्या कहते हैं? Alternate pair of angles. So angle BCO is equal to angle BAO. Reason? Alternate pair of angles. ये थोड़ा लंबा है. मिल गया. AA corollary, AA criterion. So the two triangles are similar. So you will get equal ratios and then alternate. So you get the answer. Got it? चलिए पहले मैं ये बताता हूं. Okay. CD. Okay. AB is parallel to CD and AC is their transversal. AC is their transversal. By data, वो डेटा में ही है. करेक्ट. ये पैरेलल है और AC डेटा में है. डायगोनल. Therefore, be careful children. D angle DCA. Angle DCA is equal to angle CAB. Angle CAB. Reason? ब्रैकेट में लिखे हैं. Alternate pair of angles. Alternate pair of angles. Children, हमें ऊपर ग्रीन वाला है DCA, लेकिन मुझे तो DCO चाहिए. सिर्फ इतना एंगल, वो ट्राइंगल का. So I can write that. Therefore, angle DCA is equal to यहां भी CAB, but I want only OAB. So I can write that. और वो तो ब्लैक ही है. So I'll write angle OAB. OAB. This is result 1 because A dash, O dash, see common angles. Correct? And vertically opposite angle you will get directly. Vertically opposite angles you will get directly. You can write directly, right? So now you have in triangle green COD and triangle black AB, AOB, AOB. चलो ग्रीन पार्ट पहले लिखो. ये एंगल DCA is equal by 1. I'll use black pen here. And here, बोलो green angle. Angle COD. Angle COD is equal to angle AOB. Reason? Vertically opposite angles. Correct? चलिए, I'll use the black pen now. Well, DCA is equal to angle OAB. Correct? Angle COD is equal to angle AOB. Right? Finished. Two angles, corresponding angles are congruent, equal. Therefore, a correspondence. Green का लिख देता हूं. Green I'll write. COD corresponds to dash 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 is a similarity. Is a similarity by AA criterion. Okay, by AA criterion. अब ब्लैक में क्या आएगा? दो एंगल है. You can write directly. C corresponds to A. Green C first, तो ब्लैक A first order में आना चाहिए. O corresponds to O. मिडल में O, मिडल में O. A और O already involved. The left out is B. उसको fill in the blank करो. ये blank हो गया. Therefore, you got. Therefore, बोलिए CO upon AO is equal to, बोलो बोलो, DO upon BO. मिला के नहीं? मिला के नहीं? क्या प्रूव करना है? AO, हाँ, O इनवर्स है, इन्वर्टेंडो करना पड़ेगा. AO नीचे है ना, therefore AO ऊपर है, यहाँ नीचे है, therefore AO upon CO is equal to BO upon DO. ये इन्वर्टेंडो नहीं करना पड़ता यदि आप यहां ब्लैक लिखते और यहां ग्रीन लिखते, तो ये जान लो. सो व्हाट वी यूज्ड हियर? इन्वर्टेंडो. अभी भी रिजल्ट मुझे नहीं मिला. देखो AO के ऊपर CO है, यहां AO के ऊपर BO है, सो ऑल्टरनेंडो करेंगे ना, ऑल्टरनेंडो. CO वहां ले चलो, देयरफॉर AO अपॉन BO नीचे और CO ऊपर, DO alternando. All right, and this is proved. Got it? Sure. You look at MO. MO is line L, so instead of MO you can say L. L is parallel to CD. Let's call result 4. Okay, now you know L is already parallel to AB. This line L taken is parallel to AB. So if you say this is fifth result, by 4 and 5, yeah, AB and CD. This AB and CD, they are parallel to same line L. So by transitivity you can say by 4 and 5, AB is parallel to CD. Proved. I hope you understood. We will write it nicely now. Okay? Chaliye. I think I can remove the statement. I'll write the data and to prove, and then I'll remove the statement. Correct? Okay. Let's see. What is data here? Diagonals AC and BD of quadrilateral ABCD intersect at O such that, what is that? AO upon BO is equal to CO upon DO. To prove, what do you have to prove? Well, quadrilateral ABCD is a trapezium. All right? Sure. Fine. I'll remove this so that I have enough space to write the proof. Okay. I'll start from here, and if required, I'll use this space, right? It will be required, definitely. Fine. Children, instead of line L, can I say MN? Okay, line MN or L. You can say L or M. Okay, that also I'll say fine. Proof. Well, I told you that situation is not there where you can use theorem 6.2. So you need one line parallel to AB. Let L, bracket में लिखते हैं AB. Sorry. Line MN, that is L, be parallel to AC, and that I am going to call it result number 1. L is parallel to not AC, it is AB. All right. Therefore, in triangle ACD, I'm not going to write. See, MO intersects AD and AC. Well, children, I made mistake. It is parallel to AB, right? It is parallel to AB. So I picked up the wrong triangle. ACD nahi. ABD. In triangle ABD. I'm going to put dot, dot, dot. You have to write that. In triangle ABD, what you have? MO intersects AD and BD in point M and O and is parallel to AB. It is parallel to AB. Therefore, you have that ratio MD upon MA. MD upon MA is equal to what? ODDO upon BO. Call it result number 2. अब डेटा में जो है वो लिखते हैं now. ऐसा ही कुछ है AO upon BO. You can get that ratio, but you will have to do something here. Now AO upon BO is equal to CO upon DO by data. Correct? Alright? But what you want is DO upon BO. तो इसका alternando कर दो, है ना? Therefore, DO goes there, BO remains down, CO remains as it is, AO goes down. Alternando. You used alternando, and let's call this result 3. DO upon BO, DO upon BO by Euclid's property. So you can say by using Euclid's property in 2 and 3, we get what we get? MD upon MA. MD upon MA is equal to what we get? Yeah, what we need? These two are equal. So this CO upon AO, correct? MD upon MA is equal to CO upon AO, correct? Look here, and that is now in triangle ACD. Let me call 4. Thus, in triangle ACD, there you are having what? MD upon MA is equal to CO upon AO by result 4. Array in triangle ACD, if MD upon MA is equal to CO upon AO, then line MO is parallel. Therefore, MO is parallel to CD, the third side, by theorem 6.2. By theorem 6.2. But MO, you can say MN. कह सकते हैं कि नहीं कह सकते हैं? या L. Therefore, MN is parallel to CD. Result number 5. MN is parallel to CD because M dash O dash N. Because M dash O dash N. Got that, children? Now look here. This MN is parallel to CD. In result number, this MN is parallel to CD. That is in result number 5. And same MN is parallel to AB. Same MN is parallel to AB in result number 1. So that means CD and AB are parallel to same line MN from 1 and 5. So from, by 1 you may write. By 1 and 5, it follows that. What? CD is parallel to AB, AB is parallel to CD. ये parallel. Array, one pair of opposite side parallel. Therefore, quadrilateral ABCD is a trapezium. Proved. Finished. Got it, children? Sure? Alright. So let's move further now. Theorem 6.3 is AAA theorem. I've already explained to you earlier. Theorem 6.4 is SAS theorem. And theorem 6.5 is SSS theorem. All these three theorems are for similarity of two triangles. Here, say suppose PQR corresponds to ABC. So when this correspondence is similarity, if angle P is equal to angle A, angle Q is equal to angle B, and angle R is equal to angle C. And if corresponding angles are equal, then the correspondence is similarity. I have not written the statement because it is already explained to you. Okay? Chalo. Now this is, but we will be never using A theorem. We will be using A criterion. उसमें क्या? If two corresponding angles are equal, then the correspondence is similarity. Is that clear to you? Okay. Now SAS theorem. Well, same. Two sides. Let's pick up. Pick Q upon AB is equal to QR upon BC. Only two corresponding sides are in proportion, and the included angle PQ और QR के बीच included angle Q है, यहां से भी पता चलता है angle Q is equal to B. Angle B is the included angle. So if two corresponding sides are in proportion and included angles are equal, then the correspondence is similarity. This is SAS theorem. And this is SSS. If PQ upon AB is equal to QR upon BC is equal to PR upon AC, then the correspondence is similarity. Correct? By SSS theorem. Got it, children? Sure? Okay. So now all the sums that we are going to see will be based on this three theorems. We won't be using AAA theorem. Instead, easier and shortcut is AA criterion or AA corollary. Is that clear? Just now we have seen sum number 10. It was a bit lengthy, but you can do it very easily by SAS theorem. So let's see the other method to solve example. Yes, sum number 10 of exercise 6.2. Yeah, it is exercise 6.2, sum number 10. I won't write the statement, we have just seen. What was given? One quadrilateral was given, correct? A, B, C, D. The diagonal AC and the diagonal BD intersect each other at O. Data such that AO upon CO is equal to BO, correct, upon DO. This was given. ये डेटा में था और कुछ मैंने नहीं लिखा. To prove trapezium, I am writing in short. You can't write this because I have written in the earlier sum. Okay, now I am going to use my trick. See, I will start proof with this. Children, two corresponding sides are equal. Sorry, two corresponding sides are in proportion. That is what we get from here. So we can think of using SAS. Let's see. But AO is the side upon OC. नहीं, वहां OC नहीं चाहिए. AO and BO. Okay. I'm sorry, huh? It was given this in the statement. Statement में कुछ ऐसा है. AO upon CO. ये तो एक ही लाइन में आ गया. This upper part, numerators, should be of the same triangle. So पहले alternando कर देते हैं. AO upon BO is equal to CO upon DO by data. Therefore, alternando AO upon BO is equal, CO नीचे लाते हैं, BO उधर ले जाते हैं, DO. That is result 1. Alternando. Okay? चलो. अब देखते हैं ये AO और BO, ये ट्राइंगल नीचे का ट्राइंगल यू कैन थिंक, और ये CO और DO, ये ट्राइंगल. Hey children, vertically opposite angles are equal. Also, angle AOB is equal to angle COD. Angle COD result to and vertically opposite angles. Are you getting me? Hurry. AOB, that AOB angle O is included angle of AO and BO. COD, that is O, included angle between CO and DO. So two corresponding sides are in proportion and included angles are equal. So correspondence is similarity. Therefore, a correspondence. चलिए रेड का लिखता हूं. रेड ट्राइंगल का नाम है AOB, corresponds to dash dash dash, is a similarity by SAS theorem. Okay. अब ब्लू ट्राइंगल का कौन सा ले? कोई एंगल है. एक corresponding एंगल इक्वल है. O corresponds to O. Red O बीच में, so blue O बीच में. Now that you know O corresponds to O, you can, O corresponds to O, ये ट्राइंगल और ये ट्राइंगल लेना है, ब्लू ट्राइंगल नीचे है, रेड O corresponds to blue O, पक्का पता चल गया, so red A corresponds to C, A corresponds to C, fill in the blank, D, therefore क्या मिला, एंगल A, यहां से लू रेड वाला, यहां से मिला एंगल C, the blue one, are you getting me? Therefore एंगल A, लेकिन मुझे लिखना पड़ेगा BAO, एंगल BAO इज इक्वल टू, C को लिखना पड़ेगा DCO, एंगल DCO, राइट, बाय CPCT, बाय CPCT. Now instead of BAO I can write BAC, angle BAC is equal to, instead of DCO I can write DCA, one and the same angle, angle DCA, because A dash O dash C, A dash O dash C. Now look children, ये साइड, ये सर्पेंटाइन लाइन, ऐसी लाइन नहीं आती है, सर्पेंटाइन लाइन मैं कहता हूं, ये सर्पेंटाइन लाइन और ये सर्पेंटाइन लाइन, ये एंगल और ये एंगल, they are alternate angle, so AC is transversal of CD and AB, but alternate angles are equal, alternate angles are equal, so these two lines are parallel. IE, see what I am writing after this, IE, alternate pair of angles formed by transversal, कौन सा ट्रांसवर्सल, AC of कोप्लेनर लाइंस, कोप्लेनर लाइंस, ये लाइन एक ही प्लेन वाले कौन से, AB and sorry yeah AB and CD are equal or congruent, therefore AB is parallel to CD, AB is parallel to CD, proved. I hope you have followed that. We shall continue to solve more sums based on AA criterion, SAS theorem and SSS theorem. So that's all for today. Bye bye.